Alright, so in this unit we want to talk about something called sequences and series. And a really simple definition of a sequence is just a list of numbers, like those three examples that you see right there. So our goals for this section, we want to know, first of all, there's a specific type of sequence called an arithmetic sequence. I know that looks like the word arithmetic, but usually it's pronounced arithmetic in this example. So first of all, what's an arithmetic sequence? How do you find terms? And terms just mean members of that sequence. So like on number 1, the terms of that sequence are 1, 3, 6, 10, and 15. And then finally, how would you find the formula for an arithmetic sequence? They're giving us a bunch of numbers, but is there some kind of general formula we could use to apply to all members of that sequence? So that's our goal for this section. So again, a sequence is a list of numbers. An arithmetic sequence is a list where we go from one term to the next solely by adding or subtracting. Okay, so the number that we add or subtract, if it is an arithmetic sequence, the name for that number is called the common difference, because it's a difference that all members of the sequence have in common. So we have three examples here. We just want to find out basically two things. Is it an arithmetic sequence? And then if it is, what would the common difference be? So let's try to find a pattern. So to go from 1 to 3, we went plus 2. To go from 3 to 6, we went plus 3. Here we went plus 4, and here we went plus 5. So you might say, well, sure, there's a pattern right there, and that's true. But remember, common difference means, and I should add this, it's always the same number. We have to be adding or subtracting the same number, and here we're not. Here we're increasing by 2, and then by 3, and then by 4. So this is not an arithmetic sequence. Okay, we are not adding and subtracting by the same each time. Right here, from 14 to 34, we're going up 20, then we're going up 20, and then up 20, and so on. So in this case, it is a arithmetic sequence because we're always increasing by the same common difference. And usually we symbolize common difference with the letter D. In this case, D would be 20. Alright, this last one right here, we're going down by 9, then we're going down by 36. Then we're going down by 144. So this is definitely not a common difference. Now you might notice that there actually is a pattern. To get from negative 3 to 12, we would do times 4. To get here, we would go times 4, and so on. So the pattern here is not adding, it's multiplying. And that's a different type of sequence. It's not an arithmetic sequence. It's what's known as a geometric sequence when you multiply by the same number each time. And we will talk about that in a future video. So the last thing I want to show you for this section is how to take things that are arithmetic sequences and find future terms. So in these two examples, we want to find the next 4 terms, the 100th term, and then something called the general, or another name for it is the explicit formula. So let's start by finding the next 4 terms. So it looks like we're going down 7 there, going down 7 again, down 7 again. So if we keep that going, down another 7 would be negative 11. Then negative 18, then negative 25, then negative 32. So we took care of the next 4 terms. Now here's the problem. If you want to find the 100th term, you could keep doing that again and again and again, but that would take a really long time. So the question is, do we have a better way to do this? And we do. Here's how you can do it. Think about it this way. To get to the second term, we did minus 7 one time. Right? We went from 17 to 10, we did minus 7 once. To get to the third term, we started at 17, and then we did minus 7. We did that 2 times. We did that twice. To get to the fourth term from 17, we did minus 7 1, 2, 3 times. So we did it 3 times. So you can probably see the pattern. To go to the second term, we subtract 7 once. To go to the third term, we subtract 7 twice. To go to the fourth, we subtract it 3 times. To go to the 100th term, think about it for a sec. How many times would you subtract 7? And the answer is you would subtract it 99 times. So here is the general formula for arithmetic sequences. If you want to find what's called the nth term, nth means whatever term we're interested in. So if we're interested in the third term, n is 3. If we're interested in the fourth term, n is 4. We're interested now in the 100th term. Okay, the way that you would write this is a sub n, and that is another way of saying the nth term. I believe a stands for arithmetic. So the nth term of an arithmetic sequence. The way that you find that is you take the first term, which is a sub 1, that stands for the first term, and then you add to it the common difference, which in our example is negative 7. How many times do you add the common difference? Well, if you want the 100th term, you would do it 100 minus 1 times. You do 99 times. If you want the fourth term, you do it 3 times. We want the nth term, so we're going to do it n minus 1 times. You always add the common difference 1 time less than the number of terms you want. We want the 100th term, so we're going to add it 99 times. So let's fill this in now. So a sub 100, that's the 100th term we're trying to find, is our first term, which is 17, plus our common difference, which we said is negative 7, times 100 minus 1, so 99. This, again, we're finding this n right here is the same as that n right there. So then let's find this. So 17 plus negative 7 times 99 is negative 693, and we would add those to get negative 676, and that is the 100th term. If you were to actually keep doing minus 7 all the way out to 100 terms, you get negative 676 as your answer. So see if you can pause the video and try to write this this second one. And actually, let's just one thing to note on this one, the general formula for this, because that was the last thing they asked us, the general formula is 17 plus negative 7 times n minus 1. This is what's called the explicit formula. And the reason it's called explicit is because now we can use that to find absolutely any term that we want. And one way that you could simplify this, you don't have to do this, but if you want to, you could do 17 plus, and then let's just distribute the negative 7. So negative 7n, negative 7 times negative 1 is positive 7. And so we would have negative 7n, 17 plus 7 is 24. So now this formula can be used for absolutely any formula that we want, any term that we want in that sequence. All right, let's try this one right here. And again, hopefully you've paused it and given it a try yourself. So the general formula for all arithmetic sequences is this one right here. Okay, let's fill this in, because then we can find the 100th term pretty easily. So it looks like from 6 to negative 4, and if you can't just eye it, if you can't just look at it and tell, what you can do is basically take a term and subtract the one right before. Like here's an easier example. If you had 2, 5, 8, 11, you could probably tell that the common difference there would be 3. And how do you get 3? You could do 5 minus 2, or you could do 8 minus 5, or 11 minus 8. So let's do that right here. So negative 4 minus 6 would be negative 10. Negative 14 minus negative 4, which is like plus 4, that would also be negative 10. So it looks like the common difference here, each time we're subtracting by 10. So our general formula now, we have enough to write that, is a sub n equals a sub 1 is our first term, that's equal to 6. Plus our common difference, we just found that's negative 10. And then we can simplify this a little bit. So a sub n equals 6 plus negative 10n, and negative 10 times negative 1 is positive 10. So now we will get 6 plus, actually we don't need the 6 there anymore, 6 plus 10 is 16. So we could simplify that to be negative 10n plus 16. There's our general formula, and we've taken care of this part. Let's find the next 4 terms and the 100th term. So the next 4 terms, if we keep subtracting 10, would be negative 34, negative 44, negative 54, negative 64. How can we find the 100th term? We can use this formula we just found, which is negative 10 times 100 plus 16. Or you could have done this up here. You could take our first term and add the common difference 99 times to get from the first term to the 100th term. So this is negative 1,000 plus 16, and that is equal to negative 984. That right there is the 100th term of that arithmetic sequence.